I received a very kind comment recently requesting that with that very kind comment requesting me to do this particular question, which is a proof question. It's a little bit out of the sequence of my work at the moment, but I thought to respond to that comment, I should really do this particular proof. There's a lot of proofs for this question out there, which is quite textual. It's just explanation. But they asked me if I can do maybe one that has a bit more systematic approach to it. So I decided to do this video today. So the question is simple. Is asking that with the provision that the number is prime and that number is greater than 5. So we're talking about numbers like, for example, 7, 11, 13, 19, 23, and so on. So numbers are prime numbers are greater than 5. Then if you raise them, so with a one-way implication means therefore, if we raise those prime numbers to a power of 4, then they will have a final digit. The digit on the very right-hand side of the number will always be 1. So we can assume that n, which is our prime number, can generally be can have a multiple of 10 in it, plus a final digit. And so k could be 0, 1, 2, 3, all the integer numbers, and p in our case begins with being from in a small set. So p being the final digit, a single final digit at the end of the number, will be from a small set, and that set will be 1, 3, 7, and 9. So the reason we've got this 0 included is because of that 7, because that 7 doesn't actually have any multiples of 10 in it. So when k is 0, then that wouldn't exist. So therefore, p will be from this set, which is of course 7. So if we send this n to the power of 4, so if n is sent to the power of 4, then that really be that would be 10k plus p squared multiplied by 10k plus p squared. So if I square this, I get 100k squared plus 20kp plus p squared, which in fact would need to be squared. Yeah. Now, if you look at this number, you can see that this is a multiple of 10. That's a multiple of 10. So it's 20, but it's a multiple of 10. So that will in total be a bit that will have a 0 at the end. So it will have to be a multiple of 10. And this p squared will be square of these. So it'll be 1 squared, which is 1, and 3 squared, which is 9, would be 49. So 40 would be a multiple of 10, but it would be a 9 at the end of it. And it will be 9 squared, which is 81. And that will have 80, which is the multiple of 10 in it, as well as a 1 at the end. So this would in fact eventually be another multiple of 10. So the configuration of the number that is generated would be another multiple of 10 plus a final digit. And that final digit this time, so p in this case can only be from a smaller set than before, and that set would be a 1 or a 9. So the 1 was created, the final digit 1 was created from squaring this gave us 81, and the 9 being as a final digit was from squaring this and squaring that. Squaring that is 9, squaring that's 49, so 9 is there. So again, when I square this, I get the same things. I get 100k squared plus 20kp plus p squared. And this number, which is the final number produced after the prime number being squared, will have a multiple of 10 in it, another multiple of 10 in it, and a p squared. And that p squared can be 1 squared, which is 1, and a 9 squared, which is 81. And in 81, 80 is another multiple of 10 plus 1 at the end. So the final product will actually be again another multiple of 10 plus a new p, and this new p would be from a very small set, and that set has only 1 in it, which is the final digit. Please do leave your comments on my page, wherever you see it, whether it's my blog or is any other channel that I put these videos on. I use your comments to improve my videos, and hope to see you in my next video.